this session class, no? For those who are unable to join us today. Okay? So, start tayo lang lesson today. We've covered, natapos naman natin yung ano, no? Estimation hanggang case 9.
Yes.
Okay? So, start na tayo sa um, hypothesis testing naman. Okay? So, si hypothesis testing, you'll figure out later, no, that it is actually quite similar to estimation, no? Pero iba lang yung, kumbaga, test na ginagawa natin. But you can also use the estimation na equations and just transform it slightly para maging hypothesis testing siya na equation. Okay? So, um, although importante mag-estimate ng parameters, no? For us engineers, it's always more important for us to test a hypothesis, no, or an assertion. And that is the more important na aspect na dapat natin tingnan. So let me just switch to my slides, no. So ito siya. So let's say for example, meron tayong batch. So kunwari ito. So suppose na meron tayong a batch of rebars, itong mga rebars na to. And yung rebars na yan, we took a test. Tapos, 'di ba sa estimation ang ginagawa natin is from the samples na nakuha natin, we are to estimate kung ano yung true interval or ano yung saan yung true value for which the parameter value lies within a particular range. Parang yun yung tinetest natin or yun yung hinahanap natin sa estimation, no? Pero for hypothesis testing, instead of finding that interval, parang ang gusto natin is, for example, ang nakuha natin from a batch of 20 samples na kinuha natin and 546 megapascals yung nakuha natin. So, ang in hypothesis testing, instead of saying na etong 546 or where does the or what is the confidence interval for which the true mean lies, parang ang gusto kong malaman is etong 546 ba is etong 546 na value ba is comparable to the true mean for which we do not know, no, kasi hindi naman natin malalaman yung true mean. So is 546 comparable to the true mean, parang ganun. So that is saying na etong 546 ba, pasok ba siya doon sa estimated na confidence interval. So if I were to draw it, eto. Wala ganito. So ito yung distribution natin, no? Confidence interval is saying na gusto ko mahanap itong interval na to. Okay? Hahanapin ko yung interval na to for which the true mean will lie given a certain confidence level. Estimation, that is for estimation. See, hypothesis testing is saying na if I have a particular value, does this value, for example, this one, does this value fall in this region or does it fall in this region? So labas ba siya sa confidence interval na yon or nasa loob siya ng confidence interval? So basically, it's the same lang yung hinahanap natin, no? Pero iba yung kumbaga method, yung assertion na inaano natin or assertion na pinopromote natin or ina-assert in a way, no? Okay? So in this sense, kunwari ito siya 0 to. If it falls in this region, then we say na this is what we call as the accept na region sa page not. And hopefully nabasa nyo na yung modules, no, before coming to this session, no, para mas mabilis tayo. Pero ito, this is saying na we are accepting pag nasa loob tayo ng interval na to or region na to, we are accepting. Pag dito, we are rejecting H naught. Okay? Technically, if we want to be more accurate about it, no, we are not actually just accepting H naught. Ang sinasabi natin is we fail to reject. So ito yung mas proper term, no? Fail to reject H naught. Okay? Tapos accept pero para mas simple lang yung language, no? We just use accept H naught, no? But the statistics na mga purist will tell you na mali yung statement na to, no? We are not accepting H naught but we are failing to reject H naught. Okay? But for this course, okay lang na gamitin natin yung term na to, no? Accept H naught. Okay? So, but what is H naught and HA in the first place, no? And I think kahit ito na-discuss na konti sa high school, no? And this is also discussed in the module. This is H naught is known as your null hypothesis. And sa null hypothesis natin, parang sinasabi natin na ito yung status quo, no? Tapos yung HA, this is the hypothesis that we are asserting. So we call this as the alternative hypothesis. Okay? So again, hypothesis is just an assertion concerning one or more populations. So whatever we are trying to measure, no, or we are trying to get we are testing the hypothesis of. Tapos we can have two types of hypothesis. Yung alternative hypothesis, which is minsan HA, minsan H1 yung label niya. But null hypothesis is also always H naught, no. So ang null hypothesis natin is always the opposite of the alternative hypothesis, and vice versa, no? Alternative is opposite uh, to the null hypothesis, and it is the logical complement of H1. So for example, if ang null hypothesis mo is there is no significant relationship between factors A and factor B, then the alternative is there is a significant um, relationship between factors A and factors B. Okay? So again, ang alternative hypothesis is the question to be answered or the theory to be tested. Tapos usually itong null hypothesis, this is the status quo, no? So for example, if we have ang status quo natin parati is walang relationship ang mga bagay-bagay, no? So for example, there is no relationship between the color of the sky and the temperature of the melting pot, parang ganun. So wala silang relationship. Now if you want to assert na if you for example gusto mo i-assert na may effect yung color ng sky doon sa melting pot nyo kunwari, then that is your alternative hypothesis. So whatever is the theory that you are testing, yun yung magiging alternative hypothesis natin. Okay? So again, ito siya. So ito yung region kung saan tayo nag-accept ng null hypothesis or fail to reject the null hypothesis. Tapos dito sa ends natin, sa tails natin, this is the region where we reject the null hypothesis. So if this were in terms of confidence interval, sila yung ito yung region outside of the interval. Okay? Okay. So ito, hindi na natin siya ano no, pero ito yung steps in steps that we need to take when we are doing hypothesis testing. So number one is we state the null hypothesis, which is your H naught. Tapos state din natin yung alternative, which is H1 or HA. Okay? Tapos you can have multiple alternative hypothesis, no? So kaya siya naka H sub 1 kasi pwedeng magkaroon ka ng H sub 2, H sub 3, etc. depending on the statistical test that you are doing, no? So for example, if it is kunwari multiple way ANOVA ka, then you can have multiple alternative hypothesis, no? Pero for etong simple lang na hypothesis testing na gagawin natin today, isa lang yung magiging alternative hypothesis natin. Okay? Then you choose a fixed significance level, alpha, and this is your error value. Tapos etong alpha value natin, no, hindi siya pwedeng baguhin after mo ma-test. So for example, if you stick with 10% tapos lumabas na you accept the null hypothesis, then hindi mo pwedeng sabihin na baguhin ko na lang yung alpha level ko para maging favorable sa akin yung yung results. So bawal yun, or hindi naman technically bawal, pero kumbaga hindi siya good practice, no? Good statistical practice when it comes to doing experiments. Okay? So actually medyo divided yung community, no? Yung scientific community about this, because some argue na yung level of significance kasi is should not be treated as a parang parang hard rule siya. Dapat flexible siya kasi kumbaga ang sinasabi natin is at some particular level of significance na my theory is kumbaga significant yung alternative hypothesis ko. Pero at another level of significance, posibleng hindi siya ano siya. So parang this is where confidence levels comes into play, no? So for example, if I have a p value and later I'll show you what p value means, no? Pero that is another way of relate another way of examining hypothesis testing instead of looking at or instead of fixing your significance level and comparing your test statistic with an established na critical region, ang gagawin natin is we find a p-value and we say na for this particular level of confidence, ito yung for a particular level of confidence, magiging significant yung alternative hypothesis ko. Parang ganun. Okay? So later, magpapakita ako ng examples where we use alpha, tapos magpapakita din ako ng examples where we use p-value. And you'll soon realize na, or hopefully you'll realize na for engineers parang mas appropriate nga yung p-value. Tapos kung purist ka, statistical purist, mukhang mas gusto mo na mag-stick with the significance level na alpha. No? Okay? So after choosing a fixed significance level, we choose an appropriate test statistic and establish the critical region based on the test statistic. And to be fair pala, babalikan ko lang tong no, yung argument ng alpha versus p-value is that sa alpha naman, kaya nila yung mga purists na nagsasabi na dapat hindi mo babaguhin siya. Dapat kung ano yung sinet mo, yun yung mo-proceed ka na experiment using that significance level is because ito yung pinaka-unbiased way of doing experiments. No? So, in a way, hindi ka nagpe-prevent siya ng mga yung, I forgot the term, pero parang salting ata yung tawag nila. Scientific salting, parang ganun. Because may tendency kasi lalo na pag sa research world, no, sa academic world, minsan hindi kasi nire-reward masyado pagka no, pagka ang results ng experiment mo is accepting the null hypothesis, no. So when yung results mo does not reject a null hypothesis, usually parang ang tingin ng scientific community, no, or at least most of the scientific community, tingin nila failure yung experiment mo. So kahit kahit nung high school siguro na experience niyo to, kunwari hindi kayo nakakuha ng favorable results such that yung hindi nyo na reject yung null hypothesis, no, or hindi na assert yung or hindi na prove yung assertion nyo na may significant siya na effect. Parang kino-consider natin na ibig sabihin mali yung experiment nyo, pero hindi dapat siya ganun, no? Kasi if you think about it, parang kumbaga nagdagdag ka pa rin sa scientific body of knowledge nyo kasi parang na-establish mo through testings na hindi nga hindi walang significant relationship yung certain na factors na inaaral nyo. Parang ganun. Kaso again, pag sa scientific community nga, lalo na pagka no, incentivize siya, hindi kasi, wala kasing incentive makukuha madalas yung mga researchers pagka accepting the null hypothesis yung na nakuha nilang result. Okay? So always may incentive pagka may nag-reject ka ng null hypothesis, no? So that's why sinasabi nila na minsan dahil doon sa pressure na yun na kailangan mag-reject ng null hypothesis, parang minamassage nila yung data nila such that kumbaga mag-fit siya doon sa narrative na gusto nilang i-pursue, no? So kaya yung mga purists gusto nila i-fix yung significance level alpha para whatever yung results mo lumabas, magiging unbiased siya. Ganun, if that makes sense, no, yung ganung line of thinking. So ako, I'm not entirely sure on which side I am, pero when I do experiments, I usually do p-values, no, instead of yung significance level alpha. Okay? So we choose an appropriate test statistic and establish the critical region based on this test statistic. So if we If we were to draw this, parang dito sa ano natin, itong board natin. So establishing a region is just saying na drawing tayo ng ganito. Tapos, ito yung critical value natin. Okay? So mag-establish tayo ng critical value. Anything to the left of this critical value or to the right of this positive critical value here will be the reject region. Parang check. Tapos, ito yung reject. H naught. Tapos, pagka dito, accept H naught tayo. Okay? So, ang goal dito is, if this were a symmetrical na symmetrical to na distribution, then we accept H naught if our computed value, so for example, if our test statistic is here, if our test statistic, we call this as, let's just say na we are computing for T values, no? So if our T calc, kunwari ganyan, this is our test statistic, the T value, is greater than the T crit. Minsan, instead of T crit, T tab yung ano nila, no? So meaning tabular data. So pwedeng T crit or T tab, whatever you want to call it. So if T calc is greater than T crit or T tab, then you reject the H naught. Reject H naught. If less than naman siya, again, T crit and T tab is just the same, no? We accept H naught. Okay? Okay. So, later na lang yung p-value no, na interpretation. Okay. So, after we test if the test statistics is in the critical region or not, then by the way, yung critical region natin is the tails, no? So, yun yung critical region natin. Tapos, from there, we can draw our scientific or engineering conclusion. So, this is just saying na pipiliin nyo kung yung null ba or yung alternative hypothesis yung isa-state nyo, no? Okay? So, etong p-value approach, so I've touched on this briefly, no, doon sa previous na discussion kanina. So, is defined as the smallest level of significance that would lead to the rejection of the null hypothesis. So, mas madali siyang maintindihan kung if we think about it in terms of a graph, no? So, parang ganito. So, instead of so, dito, di ba, ang ginagawa natin is we are looking for a test statistic T-calc, tapos i-check natin kung pasok pa siya dito sa critical region. Tama? Yun yung ginagawa natin sa parang pagka yung alpha na approach. Pero ang sinasabi dito sa p-value approach is, if I have my t-value, so itong t-calculated ko na ganyan, then I can establish a region for which it is significant. Parang ganito siya. So for example, if yung p-value ko na nakuha dito is so let's just say alpha is equal to 0.05, no? And since divided by 2, 0.025 siya. Dito alpha is 0.025, dito alpha here is 0.025 also. So yung p-value dito, yung sinasabi dito is sinasabi mo na, and this is if it's a two-tailed test, then you also have a p-value dito, no? So let's just say 0.05 na lang para hindi tayo malito, no? So p-value, meron ka ding p-value dito sa part na to kasi symmetrical siya. Okay? So at since two-tailed test to, ang mangyayari is meron kang value dito, we call this as the p-value. Tapos i-add mo tong two p-values na to. So just say na minumultiply mo siya, no? And let's just say na yung nakuha natin dito is 0.01, no? So if you multiply that by 2, so that's our p-value is equal to 0.02. So I'm saying na at a level of significance of 0.02, my assertion is correct, no? Okay? Parang ganun. Or at a level of significance of 0.02, kaya ko nang mag-reject ng null hypothesis. Okay, so hindi mo kailangan kumbaga i-compare dito sa alpha, pero if you want to compare this to alpha value, so pwede kong sabihin na if p-value, so magiging opposite yung nila, no? Yung magiging criteria mo dito. So if p-value is less than alpha value, So I'll just say P na lang. So if P is less than alpha, then I reject the null hypothesis. Tapos if P is greater than alpha, I accept the null hypothesis. Okay? So notice na opposite sila, no? Kasi pag mas maliit tong area na to, meaning mas kung magkapasok ka doon sa critical region. Tapos pag mas malaki yung area, kunwari, ang p-value mo is this one. This is your p-value. Then labas ka sa, kumbaga yung equivalent niya na calculated value is outside of the critical or inside the, outside of the critical region. No? Okay? So nagme-make sense ba yun? So kaya mas okay ang p-value kasi for me, no, okay ang p-value kasi kunwari, ang results ko is my p-value is 0.06%. 0.06 yung nakuha kong p-value. So if I use yung alpha test, no, parang ang magiging results ko is that we reject the null hypothesis, no? So there is no statistical difference or statistical na relationship with whatever factors I'm looking at. Pero I can also say na um, at a significance level of 6%, there is a relationship between whatever factors I'm looking at. So, kumbaga, in a way, you can think of p-value as more versatile, no? Or mas maraming information kayong nakukuha sa kanya. So, or mas nako-convey niya kumbaga yung yung results ng experiments nyo. If that makes sense, no? So, for example, the way we interpret this kasi, no, itong mga tails kasi parang ganyan, the lesser the area, parang the less likely that that the results of the experiments are due to chance. Kasi again, this is a probability distribution, no? So ang sinasabi lang kasi ng mga hypothesis testing na to is that if lower yung area na kina-cover ng results sa experiment nyo, para sinasabi niya na unlikely na yung results ng experiment ay due to pure chance alone. So it is likely caused by the variations that was due to the introduction of whatever factors na sinasabi mo or ini-introduce mo. Okay? So pag malaki yung area niya, then lumalaki din yung yung probability na due to pure chance lang talaga siya and hindi dahil doon sa factors na ina-analyze mo. So let's just say na ano, no, yung blue, yung color ng sky versus temperature ng melting pot. So ang result ng experiment mo is around kunwari 30% na alpha, na p-value. So parang sinasabi mo na 30%, may chance na 30% ay due to chance lang na yung sky is related to the melting pot na temperature. Tama? Pero kung ang results mo is kunwari ang results is 0.01%. So or 1% na ano no p-value. So parang there is a 1% chance na yung relationship ng sky at yung melting pot is due to chance, but that is a very small chance that we can say na scientifically parang or statistically kaya nating i-assert na baka nga may relationship silang dalawa. So the smaller the chance that it is or the smaller the area or the probability that it is purely by chance alone, then the more likely that there is a relationship between whatever yung tinitingnan natin, no? Okay? So to learn more about this yung baka kasi nalilito kayo sa examples na binigay ko, no? There is actually a good documentary about this, no? And it's an interesting documentary. Fiko matutuwa kayo doon. I-send ko sa inyo yung documentary na yon. Tapos mas ine-explain niya doon meron siya mga visual examples, no? Actually, pwede natin panoorin ngayon. I can just i-clip ko na lang yung small part of it that is important to. Ito. Hanapin ko lang class. Okay. Eto, send ko. Ilagay ko in chat pero siguro oh, sorry. Na-send ko kay Marty. Send to everyone. Ilagay ko in chat yung link to the video pero most likely ilalagay ko rin to sa Ublen, no? Para mas makita nyo siya. Pero may certain portion dito. Sige lang kasi. Hinahanap ko yung timestamp na eto class. This would be pretty interesting para sa inyo din, no? Itong portion na to. Narinig ba yung sounds ng PC ko? Share sound. Kailangan ko ito share sound. Ayan.
1920s and 30s
Ayan, narinig.
that a British
Yes, sir.
Okay, thank you. So ito. Panoorin natin ito class, no? Itong portion lang na to about how the alpha and p-value works, no?
scientist, Ronald A. Fisher, laid out guidelines for designing experiments, using statistics and probability as a way of judging results. As an example, he told the story of a lady who claimed to taste the difference between milk poured into her tea and tea poured into her milk. Fisher considered ways to test that. What if he presented her with just one cup to identify?
Saglit na. Saglit lang class, no? Ano nangyari?
Skill.
Wait. Stop share. Ulitin natin. I-share ko na lang. Ayan. Kita ba yung shared screen?
Yes, sir.
Okay. Ulitin natin yun, no? Yung part na...
The lady then had to separate them
Oh, ito.
one cup to identify. The story of a lady who claimed. Fisher considered ways to test that. What if he presented her with just one cup to identify?
If she got it right one time, you'd probably, well, yeah, but she had a 50-50 chance just by guessing of getting it right. So you'd be pretty unconvinced that she has this skill.
Fisher proposed that a reasonable test of her ability would be 8 cups, 4 with milk into tea, 4 with tea into milk, each presented randomly. The lady then had to separate them back into the 2 groups. Why 8? Because that produced 70 possible combinations of the cups, but only 1 with them separated correctly. If she got it right, that wouldn't prove she had a special ability. But Fisher could conclude, if she was just guessing, it was an extremely unlikely result, a probability of just 1.4%. Thanks mainly to Fisher, that idea became enshrined in experimental science as the p-value, p for probability. If you assume your results were just due to chance, that what you were testing had no effect, what's the probability you would see those results or something even more rare?
If you assume that there's a process that is completely random and you find that it's pretty unlikely to get your data, then you might be suspicious that something is happening. You might conclude, in fact, that it's not a random process, that this is interesting to look at what else might be going on, and it passes some kind of sniff test.
Fisher also suggested a benchmark. Only experimental results where the p-value was under 0.05, a probability of less than 5%, were worth a second look. In other words, if you assume your results were just due to chance, you'd see them less than 1 time out of 20. Not very likely. He called those results statistically significant.
Statistically significant.
Yeah. So I hope that gives a better, or it paints a better picture, no, sa yung sinasabi ko kanina, class. So you can watch the documentary on your own. No? Actually, very interesting yung documentary natin. It touches on probability, tapos marami din siyang ano, no, aspects na importante sa ano natin, sa statistics class natin. Okay? Tapos share ko lang ulit yung balik. Ano yung nakita niyo sa screen? Yung mukha ko ba?
Yes, sir.
Sorry. Pero ito ngayon, tama na yung nakikita niyo sa screen.
Opo.
Okay, sige. Thank you. Okay. So, again, yun yung difference between yung 0.05 na established na yun yung parang alpha value, no? So, kaya in practice, lalo na pagka for mga researchers, no, scientific researchers, no, yung hard science na research, usually 5% yung parang benchmark na alpha value. Pero pag yung research is mostly social sciences, no, ang common ata, if I remember correctly, no, for social sciences mas less lenient sila. Parang 10%, parang okay na sa kanila yung 10% na alpha, no? Because parang mahirap kasi mag-control ng variables when it comes to social sciences, no? Kaya mas malaki yung parang wiggle room nila, if I should say so. Okay? So, okay. So, try tayo ng isang example, no? Okay. So, let's try case 1 first, yung single mean lang. So, we can have we can have three possible na alternative hypothesis, no? So, we are saying na if it's a one-tailed test, pwedeng nasa left siya. So, this is where yung alpha mo, ilalagay mo lahat dito sa left tail. Tapos, pwede rin nasa right tail yung alpha mo dito sa side na to. Okay? So, if your mu is less than mu naught, then nandito ka sa left tail test ka. Tapos pag if your mu is greater than mu naught, then right tail test yung gagamitin nyo. Pero pag ang sinasabi mo is if you use a two-tailed test, then you use mu is not equal to mu naught. And in most cases, no, we like to write the alternative hypothesis as a inequality, no? Tapos always si null hypothesis as an inequality siya. Okay? So, sinasabi dito is instead of finding kung nasaan itong mu na to na value, ang ina-assert natin is kung yung mu naught na nakuha natin from the experiment is statistically comparable to the mu value. So hindi totally equal, no? So for example, kung nakuha ko is ang true mean is 550, kunwari ganyan, no? Tapos ang nakuha ko is 550.07, kunwari ganyan. Yun yung nakuha kong value, no? Sorry, hindi pala ano. Okay, thank you for the reminders, class. Ito, sana nakikita niyo yung PowerPoint. Okay, so ito again, pag left tail test, ito siya. This is a visual representation of the left tail test. So we are comparing mu, no? So mu here is the population, mu naught here is the sample. Okay? So parang ang sinasabi is yung mu naught, yung sa binigay ko example about the rebars, no? So is the mu naught na nakuha ko ba comparable to the mu value? Okay? So you can have three possible alternative hypotheses. If you're using one-tailed test, then there are two cases, no? Pwedeng nasa left siya. So I'm saying na mu is less than mu naught, or nasa right siya tulad nito, which is saying na mu is greater than mu naught, no? Tapos pagka inequality naman siya, gagamitin natin is not equal to mu naught. So this is mu is not equal to mu naught. Then parang is-split natin, this is the two-tailed test, no? Is-split natin yung alpha value natin doon sa left and right tail. Okay? So dito, the null hypothesis again is is always stated as an equality, no? So, for example, mu is equal to mu naught, pero this does not mean na equal talaga yung values nila. Parang we're saying na statistically comparable siya. So, that is, for example, ang true value is 550 kunwari na megapascals. Yun yung yield strength ng isang batch or isang process, no, of creating rebars. Okay? So if I got a sample that is 550.07, then mathematically hindi sila equal, no? Kasi 550 is not equal to 550.07. Tama? Pero it's close enough. So ang test is saying na kung gaano ka comparable yung nakuha mong statistical value versus doon sa true value ng whatever process or whatever batch you are looking for. Okay? So again, yun yung binigay ko example is medyo kung intuitively mas madali natin ma-figure out kasi kung 550, 550.07 sobrang lapit lang naman, sir. So siguro comparable yan, dalawang yan. Pero what if we get something like 570? So 550 and 570, ano yung metric natin para masabi na malapit lang ba yung 570 sa 550 or can we consider it as mas malayo na? So that is where hypothesis testing comes into play, no? So yan yung natin ginagawa when we do hypothesis testing. Okay? So let's try an example, no, para mas ma-imagine natin siya. So eto, we have 3 cases and notice na similar lang yung cases na to, no? So look at similar lang yung cases na to dun sa estimation na cases natin. So we have case 1, case 2, and case 3. And ito, if you remember, case 1 is when the population value is known. Case 1 is the population is known, pero no, sorry. This is case 1 is when your population standard deviation is known, no? So if known yung standard deviation, that is case 1. Case 2 is unknown yung population standard deviation pero we can assume it to be normal. Tapos yung case 3 natin is unknown yung population standard deviation. Tapos small size siya such that hindi natin ma-assume yung normality, no? Okay? So let me pull out the yung formula para makita natin kung paano yung comparison, no? So, gumakanta sa labas. What is testing? So, ito yung sa class, no? Oh, mali pala. Mali yung kinopya ko. Okay? Tapos, try lang natin i-compare class, no? And I could probably highlight this in red, no? So, yung bottom part, sila yung estimation, no? So estimation is again naghahanap tayo ng interval, no, for which the true mean lies. Pero kung papansinin nyo, yung formula is just a rearranged na value. So instead of establishing a z value or instead of looking for an interval for which the true mean lies, ang ginagawa natin is if you rearrange this error value here, so if you do or i-rearrange natin such that yung z yung hinahanap natin, then we actually get this equation, no? So try to rearrange this and let's just use yung positive na value para yung z na makukuha natin is in the right tail. So if you think about it, if you rearrange this, ang z na to. So what we do is lilipat natin sa left side, no? So the confidence interval is this one. So magiging x minus mu siya. And di ba ito kasi this is the true mean, no? So parang if I were to write this as an equation, parang magiging ganito siya. So magiging I'll just use u no, pero I'm saying mu siya. Mu, the true mean is equal to x bar plus minus itong value na to. So kung i-rearrange ko siya, so magiging x minus mu, x bar minus mu. Tapos yung z natin is on the opposite side. So di-divide natin siya. So that becomes, etong value na to, i-divide natin sa x minus x bar minus mu. Tama? So uh, we get this equation, no? Magiging z is equal to x bar minus mu naught over sigma uh, over square root of n. Tama? So if we do the rearrangement, it should be equal to this value. Okay? Actually, dapat mu minus x bar. Kung positive yung, so negative yung kukunin pala natin na C alpha. Does that make sense? Wait lang, class. Parang hindi yata nagmamatter pala, sorry. Kasi two-tailed test naman to, so hindi nagmamatter no kung nasa left or right siya. So x minus mu naught, yung difference lang kinukuha natin. So yung absolute value at yung kailangan natin dito. Kasi yung z naman na makukuha natin, if it's on the left tail, ang gagamitin natin is yung point of comparison is the negative t value. Pag nasa right tail naman siya, yung positive t value yung compare natin. Not unless sinabi talaga sa problem na na one-tailed test yung gagamitin natin. Okay? So, you see how they are just the same na equation, pero kumbaga iba lang yung interpretation natin sa kanya. So, instead of finding etong mu naught, ang hinahanap natin is etong yung z-score yung hinahanap natin. Ano yung z-score such that magiging comparable or nasa loob tayo nung interval na in-establish nitong estimation na to, na equation. Okay? Okay. So I hope that clarifies now the difference between your estimation and your tama na ba yung screen? Estimation and hypothesis testing na formula. Okay? So again, same cases siya. So we have 9 cases sa hypothesis testing, no? Tapos we have also 9 cases we have 9 cases sa estimation, tapos meron din tayo 9 cases sa hypothesis testing. Okay? So, eto, try natin yung example na to. Suppose you were able to estimate the population mean strength as 550 megapascal. So, this is, for example, kinuha mo from, from kumbaga historical data, na-estimate mo na ang population mean is around 550 megapascal with a standard deviation of 4.5 megapascals. Okay? So a batch of 20 samples has a strength of 546 megapascals. Is this obtained value still comparable to the population value? So we test it at 2 alpha significant level. No? So we have alpha is equal to 0.1 tsaka alpha is equal to 0.05. Okay? So again, ang ituturo ko method ngayon is through Excel. Tapos wait lang, klasa. Buksan ko lang Excel ko. Excel. Nasaan yung Excel? Yan. Okay, nakikita nyo ba yung Excel ko?
Yes po.
Okay, thank you. So, step 1 natin is first establish yung dapat ang step 1 natin is establish muna tayo ng mga hypothesis natin. Okay? So, let's say H naught natin is mu, the 550 is equal to or is not equal to 556. Mga ganyan. Tama? Sorry. 550 is equal to 556 pala. Okay? Tapos H1 natin is that 550 is not equal to 556. By the way, this is how we write not equal to, no? Pag, if you wanted to write it in Excel, no? This is one way to write it. So not equal to. The exclamation point here indicates na hindi ano siya, inequality siya. Okay? Okay? So or kung gusto niyo mo, pwede rin ang gawin natin is para mas malinaw, no? Yung mu natin is equal to mu naught. Pero dito, let me just say mu na lang. Mu is equal to mu naught. Tapos mu is not equal to mu naught. Okay? Which is saying na ito siya. 550 is just equal to 556. 550 is not equal to 556. So kung equal siya, sa 556, we are saying na pasok siya doon sa interval, no? So if you remember um, the curve, parang ang sinasabi natin na pasok siya doon sa interval from the left tail to the right tail. Okay? Pero pagka hindi sila equal, ibig sabihin nasa critical region siya doon sa either left tail or right tail. And obviously, since mas malaki siya, this will be a right tail na region. Okay? Pero since two-tail test yung gagawin natin, we are testing both sides, no? So magiging ang two tails natin will be or the alpha value will be split into two tails. Okay? So, yung given values doon 555 546 pala, sorry. 546. Tapos yung sigma natin is known to be 4.5. 4.5 siya. Okay? Sigma is 4.5. Okay? So this is step 1, no? And pwede siguro i-label natin para mas malinis. So we can do step 1. Now let's do step 2, no? Step 2 is after ma-establish mo yung hypothesis mo, ang gagawin natin is to choose a fixed significant level, no? So ang sabi sa problem is we can either do alpha, we are to do alpha of 0.1, saka we'll do an alpha of 0.05. Okay? Now next is step 3 is to choose an appropriate test statistic. Step 3. So ang test statistic natin is yung z-score, no? Kasi this is case 1. So we can say case 1 and therefore z-score yung gagamitin natin. Okay? Tapos after choosing the test statistic, compute na natin kung ano yung calculated value, no? So we need to calculate for z-calc and yung z-tabular or z-crit. Okay? So how do we find z-calc muna? So the z-calc is yung binigay na formula, no? And para mas tandaan nyo. And by the way, anong case 1 to, no? Kasi known yung standard deviation, population standard deviation, tapos, and therefore, pwede siyang ma-assume to be normally distributed, no? Or we can know that it is normally distributed. Okay? So, sorry, maligaw. That is for estimation, no? Gagamitin natin is yung itong value na to. Okay? So, the z calculated is just equal to x bar, and x bar is equal to 546. Sorry, 546 para, so dapat left tail test, ano? Or, I mean, if this were a one-tail test, dapat left tail yung kukunin natin. Pero again, dahil two-tail test yung gagawin natin, we are testing if on either sides. Okay? So, 546 divided minus, sorry, gawin natin 546 minus 550, and we divide this by sigma. So sigma is 4.5 and we multiply it and we etong both na to nasa divisor, no? So kung nasa divisor si square root of n, mapupunta siya sa numerator, no? So magiging, or I'm sorry, dahil 1 over square root of n ay nasa divisor, dapat square root of n ay nasa ano, no? Sa numerator. Okay? So pwedeng square root ng ano yung n natin? May binigay bang n value? N is equal to ilang samples ngayon? Sinabi ng problem, 20 samples. So from 20 samples daw to galing. So times 20. Pwede palang ginawa natin, no? Para before tayo naglagay muna tayo ng given para mas malinis yung workflow natin. So pwedeng ginawa natin ganito. Tapos mu is equal to 550, mu naught is equal to 546. So para lang mas malinis, no? Pwedeng ganito yung answer sheet natin. Okay? Okay, so that's again, compute natin ulit. X bar is this value minus mu naught. Sorry. Mu pala is the X bar, no? Tapos mu naught is 546. So mu naught is the population na value, no? Okay, so baliktad to. This is supposed to be 546 and this is 550. Okay? And ito, 546 is not equal to 550. Okay. So, let's do that again. Is equal to X bar, which is this value, minus mu naught, this value, divided by sigma, which is this value, tapos multiplied by square root of n. So, si Excel class is, pinafollow din niya yung MDAS, no? So, so okay lang sa akin na kahit nag-divide na ako tapos multiply ko siya. Unless nga nilagyan ko siya ng mga parenthesis. Pero dito, pwede lang ang gawin ko is C1 times square root of 2. Pero pwede ring i-close ko pa sa parenthesis to tapos pwede din ganyan, no? Okay? Pero para mas madali kung ganyan ko na lang siya. So I should get negative 3.97. And this makes sense, no? Because 546 is less than 550. Therefore, nasa left tayo. So, bakit sa step 1? Bakit sa step 1 mu naught yung 546? Okay na. Okay na pala. Sorry. Kanina pa pala to. Sorry, Martin. Thank you for the feedback. Okay. So, we have our Z calculated, which is negative 3.97. So, what we can do is, pwede natin kunin yung positive value niya, no? So, we can do absolute value or pwede rin i-imagine na lang natin, no? So, this is parang ganito kasi siya. So, if I were to draw it, eto, parang ganyan, no? Tapos, hinahanap natin kung nasaan itong Z calculated na negative 3.97 na to. Is it in the critical region or is it outside of the critical region? So, kung i-compare natin siya, so for example, if we take the Z crit, dapat yung negative value yung kukunin natin. Tama? Tapos, magiging opposite siya, no? Kasi since it's a negative value, para mo pumasok siya doon sa critical value, dapat negative 3.97 should be less than the Z critical para maging pasok siya doon sa critical region natin. Pero 'di ba medyo confusing kasi siya pag ganoon natin inisip. So I'm suggesting na instead of doing the negative values, no, ang gawin niyo na lang is gawin yung positive to. So pwedeng gawin natin is absolute value nito para makukuha natin is absolute value nung Z calculated natin. Okay? Tapos ang Z crit natin, and we can only do this kasi ano no, we can do this because we are doing a two-tailed test, no? So whatever is on the left tail will also be reflected on the right tail, no? So pwedeng ang Z crit natin is equal to, the way we compute for Z crit is to do norm. So norm is for the normal distribution, no? And that is where your Z scores lies, no? So we go norm this, sorry, norm dot S to signify that it is a standard, standard na value siya, or standardized na normal distribution siya. And we do norm dot S dot this. Tapos, dot inv yung ano natin. Tapos, isusulat natin yung probability. So again, si norm.s.inv is kukunin niya yung probability from the left end siya. So pag ginawa natin to, we should do 0.0, if we do alpha equals 0.1, then dapat 0.05 gagamitin natin, no? Pero again, para maging positive siya, gawin natin siya is 0.95. Parang ganyan. Okay, so this is Z crit for alpha 0.1 and compute tayo ng Z crit for alpha 0.05 naman. Okay, so ito, we do the same. Z norm dot inf dot norm dot s dot inf ng probability of 0.975. Okay, parang ganyan. So notice na ito, it's further, no? Kasi if we, and let me just draw it, no, para mas makita nyo siya. So parang ang ginawa ko dito is, if I did 0.1, so ito yung parang 0.5 na area o 0.05 na area kasi nandito yung other 0.05. Okay? Tapos yung ano naman, yung maybe it's better if dun sa i-drawing ko sa ano, no? Wait. Mamaya na lang ayusin. Hindi pa tayo sa ano, no? Photoshop para mas malinaw. Okay? So, let's do, meron tayong ganito. So, kung 0.05, kung 0.1, para siyang nandito, no? Ito siya. Hinanap natin yung Z values for which nagko-correspond doon sa 0.05 on each side. So, this is 0.05, 0.05. Now, if we do 0.25, parang sinasabi natin is nandito lang siya. So, this is in the area of 0.025. Tapos dito naman, 0.025. So, that corresponds to alpha equal to 0.05. Tama? So, notice na itong Z na to, if this is your 0, it has a greater value than this value here. Tama? And which makes sense, no? Kasi kumbaga, kung mas maliit yung area, mas further to the right siya or further to the left. Or basta ang point is mas malayo siya sa 0 natin, no? So kaya yung na-compute natin na Z for 0.05 is 1.9, tapos dito mga 1.6. Okay? So, tanong ni Martin is, so sa pagkuha po ng Z-calc and Z-crit, kailangan po yung positive yung kukunin. Hindi naman kailangan positive yung kukunin, no? Mas less confusing lang kung positive values yung kinuha natin, no? Pero sige, I can show you the kung the solution kung hindi natin ginawa yung positive value. So ito, ang magiging conclusion natin sa step 5 is, since Z calc is greater than Z crit, then we fail to reject or we accept. Oh, no, sorry. Since zcalc, we reject pala, sorry. We reject H naught. Tama? So parang if we were to draw it dito, parang sinasabi natin is yung computed Z natin is 3.9, no? So let me use another color. Yung computed Z natin is somewhere dito. Tama? Ito. And this Z value here is Z is equal to 3.9. So it's well within the critical region, no? Kasi sobrang taas niya na value, 3.9. Okay? So so that would entail na yung area niya, if we were to compute its p-value, sobrang liit niya. Tama? So, ito yung, and let's try ano, no? So ito, since zcalc is less than zcrit, then we reject H naught and tapusin lang natin. So step 6. 6 is we derive a conclusion, no? So we can say, wait lang. Sana yung ano ko? Sorry. Step 3 pala to lahat, no? Ito yung step 4. Kaya pala, ang alam ko, hanggang 5 steps lang eh. In-edit ko lang yung Excel, no? Anyway, balik tayo dito sa Photoshop. So etong 3.9, well within the region siya, no? Tama? So, kaya madali siyang i-compare, no? Kasi kung nasa positive tayo, if it's greater than, ibig sabihin further to the right siya or further within the critical region siya. Pero pagka nag-left kasi tayo, magiging confusing, no? Kasi magiging negative siya, dapat less than siya kasi more negative para maging within the critical region siya. And if I show the Excel value, you will get what I'm trying to say, no? So for example, ito, yan, since zcalc is greater than we reject, so we are saying that the sample mean is not comparable. Comparable. Tama naman. Comparable to the population mean. Okay? So yan yung magiging engineering conclusion natin, no? Right? So, now let's try na kunwari hindi natin p-positive, no? So parang magiging ganito siya. If we didn't do positive values, then we should get something like ito, negative 3.97. So we should get the left tail as well, no? Tama? So the left tail is zcrit of 1.65 is, and let me just copy this. Magiging norm.s.inf siya ng 0.05. Tama? Which is just the negative of this one. Makes sense, no? Tapos ito, norm.s.inf ng 0.025. So notice the ano, no? Parang magiging confusing yung ano mo, itong sa step 4 part kasi if follow ko to, parang zcalc is less than zcrit. Parang you will be tempted to say zcalc is less than zcrit, then I accept H naught. Tama? Kasi zcalc is this value, this is greater or sorry. Etong value na to, etong zcalc, this is less than this value kasi more negative siya eh. Tama? This is negative. Then if I will just follow the ano, no, yung parang understanding ko na if the calculated value is greater than the critical value, then we reject H naught. Then parang baka malito ako tapos i-accept ko yung H naught. When in fact dapat nire-reject ko siya. Okay? So kaya mm, para sa akin confusing pag gumamit kayo ng negative values. But the better approach is instead of looking at positive and negative values, tingnan nyo na lang yung graph. So if it's ang gagawin nyo is, kunwari, i-graph nyo kung nasaan si critical. Kunwari ganito. So the critical is, kunwari lang yung negative 1.6, no? So negative 1.6 is here. Tapos yung z-calc ko is, nandito siya. Negative 3.9. Therefore, pasok siya dito sa region na to. So pwede kong sabihin na since z-calc is within the critical region, then we reject H naught. So pwede rin ganyan. So you can do it either way, no? Kung ano yung mas komportable kayo. Ako lang, feel ko lang kasi na may chance na marami ng estudyante na nalito dito, no? Na parang since etong z-calc na to is less than etong z-crit na to na negative value, this is more negative, therefore it is less than, then I will assume na I will accept H naught to. But in reality, nasa critical region talaga siya. So dapat reject H naught yung naging conclusion. So medyo nag-gets ba yung sinasabi ko? So kayo
Sir,
bahala. Yes.
kapag kapag yung pangalawa po, yung Z-calc is within the critical region, kailangan po may support po yun ng drawing po. Po kailangan.
Hindi naman kailangan. Pwede nyo naman sabihin na critical region tapos pwede nyo sabihin na ganito na lang. Critical region tapos i-state nyo na lang kung ano yung values. Kunwari, negative 3.9798 is less than negative 1.64. Pwede nyo sabihin na ganyan.
Okay po.
So, yun. Depende sa inyo, no? Kung ano mas komportable kayo. Ako, I maybe, kung two-tailed test, I'm suggesting positive nyo na lang lahat para mas madali siya. So, positive nyo lahat para pwedeng ito lang gamitin yung conclusion, no? Since z-calc is greater than z-crit, then we reject H naught. Okay? So, let's try naman, class, no? What if ang tinatanong ng problem is a one-tailed test, no? Instead of a two-tailed test. So, we are testing that. So, ilagay ko lang siya dito copy ko lang to lahat, no? Pero ilagay ko dito. So, what if ang tinatanong ng problem sa atin is, ano to? If 546 is less than the true mean, no? Parang ganun. If x bar is less than true mean. So parang this is a left-tailed test. This now becomes a left-tailed test, no? So we are saying that h naught, x bar, our h naught is, our h naught is still mu is equal to mu naught, no? Pero this time, our h1 is saying na the 546 value, yung x bar na kinuha natin, is less than the 550 value. Okay? Parang ganito. Parang ganito yung sinasabi niyo. So obviously, it's less than 5, yung 546, no? Is obviously less than 550. Pero ang sinasabi natin is it significantly less than 550? Okay? So, pag ganyan, and we have alpha is equal to 0.05 and alpha is equal to 0.1. Let's test both cases, no? So, if we were to draw it, and balik tayo dito. Kung i-drawing natin yung scenario na to, no? What we'll end up with is something looks like this, no? So, ito siya. Tapos, mangyayari dyan is we do a one-tailed test, no? So, gusto natin i-test kung pasok ba dito sa left tail yung whatever z calculated na compute natin. So since ang 0.05, di ba, yung dati, kung if we do alpha is equal to 10% or 0.01, then hinahati natin, no? 0.05 dito, tapos 0.5, 0.05 dito, 0.05 din dito. For this time, since alpha is equal to, this is a left tail test, then lahat ng 0.05 na nandito, ililipat natin doon sa left tail. So instead of na-split na dalawang 0.05, ito, isang buong 0.1 siya. Okay? So what does that mean? Ibig sabihin na mas stringent yung test. Tama? Kasi kumbaga hindi pala stringent. Ano ba yung term? Mas focused kumbaga yung test. Kasi alam mo na less than siya, pero gusto mo lang malaman kung statistically significantly less than ba siya doon sa true mean. So, ang maganda sa test na to kasi kung if you think about it, parang ganito, no? If we have the same values, and let me draw this as, copy ko na lang. And ito, estimated lang to class, no? Pero let me just illustrate what I mean by yung mas focused yung testing natin. So if I were to do this, kunwari ganyan, same values, no? Pero this time, I'll do a two-tailed test when I'm actually trying to test if it's significantly less than. Para ang mangyayari is, I could have pwedeng dito ang 0.5, 0.05. Tama? Kung hinati ko siya, parang ganyan, nandito yung other 0.05. Then I could have something that looks like this. Tapos magiging, ang conclusion ko dito is wala siya sa critical region. So in this case, parang sasabihin ko na accept H0. Tama? Kasi pasok siya dito sa accept H0 eh. Pero dito sa case na to, same values, no? Same values. Ang difference lang is one-tailed test to. Dito sa scenario na to, pasok siya sa reject H0 region. Okay? So kaya mas maganda ang one-tailed test if you know na if you know the direction kumbaga ng whatever mean na tinetest nyo. So if I know that yung 546 na yon is less than yung 550, and I'm not saying, I'm just comparing kung if that particular mean is less than the true mean, that is my assertion, then dapat gawin ko is a left tail test, a one tail test that is on the left side. Okay? So nagme-make sense ba yun? So parang ang nangyari is yung if you really think about it, parang it's as if gumawa ka ng etong si alpha of 10% ng left tail is similar to a two-tailed test where alpha is 20%. Parang gano'n. Okay? So try natin, no? So if we were to do the left tail test, then hindi natin i-absolute value, no? Gagawin natin is zcalc is equal to negative 3.97. Tama? Tapos zcrit, gagawin natin siya is 0.05 negative, since yung buong 10% yung gagawin natin, no? So, nandyan sa 1.28. Tapos ito, yung buong 0.05 yung ilalagay natin dito. So, that's 1.64. Notice na ito is equal to dito, no? Kasi itong sa 0.1% na two-tail, hinati kasi natin into 2, so 0.05. So, therefore, it makes sense na equal siya sa z-crit. Equal siya sa z-crit na, na naka-negative value. Okay? So, ang ginawa lang natin dito is norm.s.int ng 0.1. Tapos, ito, norm.s.inf ng 0.05. So, yung buo ng ano. So, dito, magiging conclusion natin is si zcalc natin since your z-calc is within the critical region, then we reject H naught. Tama? Well within siya, no? So para sinasabi natin dito is the sample mean is significantly less than the true mean or population mean. Okay? So this is what happens when we do a left tail test, no? Okay? So again, similar lang sila, no? Ang ginagawa lang natin sa left tail test is that mas focused yung testing natin. Okay? Ang problema kaya natin ginagawa yung two-tailed, yung advantage ng two-tailed test over the one-tailed test is that if wala tayong idea sa directionality ng means na kino-compare natin, no? So let's say for example, meron tayong two means. We want to compare mean ng isang product A versus mean ng isang product B. Tapos hindi natin sure kung sino bang mas malaki yung mean. Kunwari, let's just say we're testing um, hardness or we're testing wear resistance, kunwari. So if we are testing the wear resistance of product A versus the wear resistance of product B, then we can't be sure kung product A is greater than product B or product B is greater than product A. So kung ganun yung ganun yung information lang na meron tayo, we should do a two-tailed test kasi hindi natin sure kung if one mean is lower than the other mean. Tama? Para cover natin both sa left side and both sa left side and right side. Tama? Pero if we ang assertion natin is, for example, gustong i-prove ni product A, no, superior yung product namin. Our product has higher wear resistance than the product B. Then, para mas focused yung testing natin, ang magiging assertion natin is that si product A, the mu of product A is greater than the mu of product B. And therefore, I will be doing a right tail test. So, nagets yung difference? Okay, so comment ni Martin. So one-tailed test, inassert lang yung isa sa two possibilities unlike sa two-tailed na both possibilities are considered. Yes, exactly. Parang ganun yung sinasabi Martin. No? So it boils down to the directionality ng ano natin, no? yung test na ginagawa natin. If we are looking at a value that is less than or a value that is greater than, and pwede siyang magamit sa ano, no? So yun yung isang example na yung product A and product B, yun yung clear example na makikita nyo kung saan kailangan nyo gumamit ng two-tailed or kailangan nyo gumamit ng one-tailed. So maybe I'll show you a more complicated example, no, na wherein hindi masyadong obvious kung one-tailed ba siya or two-tailed, no? Pero when we really think about it, makikita natin na okay, one-tailed pala dapat to or two-tailed pala dapat to. Okay? So, okay. So, let's try another example. Or gusto nyo ba mag-break muna saglit? Okay, diretso na tayo. So, let's do PowerPoint. No, sorry. Dito. And we do another example, no? Medyo madali na lang yung single mean, no? So, try natin yung mga examples na two means naman tayo. So, ito, meron tayong two means and we are saying na yung null hypothesis natin is, by the way, hindi ko pala na-explain yung p-value. So, balik muna tayo, no? Sorry. So, ito yung maganda sa p-value class, no? So, if you want to compute the p-value, so let's compute for p. Ang p-value is just equal to, kukunin nyo yung z-calc nyo. So, yung z-calc, sorry. We do norm dot s. Instead of doing dot inf, ang gagawin natin is dot dist. So, given a particular na value, ano yung magiging yung area under that curve, no? So, since this is a positive value, ang gagawin natin is, para makuha natin yung area, what we actually do is, we do cumulative, no? Kasi gusto natin makuha yung entire area sweeping from one portion to another portion doon sa x-axis natin. Okay? So ito, since ito ay positive value, so if we were to do normal ganito lang, sobrang laki ng value, no? Kasi parang ang nangyari dyan is, ito yung 3.99, dito si 3.9. Tapos ang kinuha kasi natin is itong buong area na to. Pero what we want is not this area, no? Ang gusto natin is this area, itong maliit na area na yan. Tama? So, para makuha yon, since the entire area is equal to 1, pwedeng gawin lang natin is 1 minus norm.s.dist. Okay? Okay? So ito, we get a p-value of a very small p-value, no? Look at this value, is very close to 0. So this tells you na sobrang liit lang ng possibility na or ng probability na ang etong z calc na to is comparable to 550, such that we can say na hindi talaga siya comparable, or statistically kaya natin ma-assert na or ma-conclude na hindi siya comparable dun sa population mean. Okay? So, loosely translated, no, parang we can say na itong 3.55 is the probability na this 546 is comparable to 550. Okay? And and because it's such a small probability, then we can say that the sample mean is not comparable to the population mean. Okay? Or another way of doing this is also, pwede ring ang conclusion nyo, if you don't do and if you do this p-value, no, hindi nyo na actually kailangan i-compute to. Okay? If you do the p-value approach, hindi nyo na kailangan i-compute si critical values, no. Okay? So ang gagawin natin is, conclusion lang natin is, since p-value is less than alpha value, then we say, then we reject H naught. And ang maganda sa p-value, no, is you don't care kung ano yung direction niya, no. So as long kasi yung p-value is always positive, makukuha mo kasi area kasi to, so it's always a positive value. Then therefore this relationship holds true always, no. Kung less than siya than the alpha value, then we reject. I'm sorry. Ito pala class, we need to multiply this by 2 pa. Tama? Because this is only the area of the right na ano, no. Since this is a two-tailed test, then we multiply it by 2. Okay? So ito yung p-value niya. So we multiply it by 2 and it's still a very small number, no? And if we do a left tail test, kung left tail yung gagawin natin, this is equal to norm.s.dist nitong value na to, and since negative na to, pwedeng hindi natin gawin yung 1 minus, no? Kasi from the left side na to. So if we do this one, cumulative ulit, the second argument should be true, no? Para ma-measure natin yung area. So we do cumulative. So true is, again sa previous lesson, no? In Excel, pag gusto nyo sabihin true, pwedeng 1 lang ilagay nyo. Tapos 0 if gusto nyo false. Okay? So we get ganitong value. So in this particular case, hindi na natin kailangan i-multiply by 2 kasi one-tailed test to. Tama? So we can also say na since p-value, okay, pwede naman ganyan lang. P-value is less than alpha for both cases, no? For both alpha 0.1 tsaka alpha 0.05, then we reject H naught. Okay? Yes, i-compare natin sa alpha value, Martin. Okay? Kenneth, how about po yung p-value ng example 1? Okay. Ito na yun, Kenneth, no? Okay. So, if you have questions, class, no, i-chat nyo lang kasi nababasa ko naman siya. Two given alpha. Paano pag magkaiba yung conclusion na nabibigay ng 2 given alpha? So, magiging iba lang yung conclusion. No? So, kunwari, ibang ang conclusion. No? So, at an alpha level, Okay, ganito. I have a level of point of 10%. The sample mean is significantly less than the true mean. Pwede ganyan, no? Pwede tapos pwede nyo lagay na but at an alpha level of 5% kunwari, blah, 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 blah. Dot, dot, dot. Pwede ganyan. Pwede ganyan yung conclusion nyo na magkaiba at different alpha values. Pero usually naman, kung research talaga to, no? Ito, for exercise sake, naglagay tayo ng 2 alpha values, no? Pero for research, if research talaga to, isa lang yung pinili natin na alpha value. And usually, kung hindi binigay, we use a alpha value of 0.05. Okay? So, maganda din na kaya sinasabi ko kanina na maganda yung p-value approach where we don't look at alpha values kasi pwede natin sabihin dito na at a p-value of 0.0000 whatever percentage this is, a very small percentage to, no? Percentage pa to? I'm curious. Almost zero. Ilang yan. At a p-value of 0.00035%, we can say that the sample mean is significantly less than the true mean. Okay? Which is a very small value, no? So, okay yung ano, kunwari, p-value, ang lumabas dito is 20%. Then parang sa nakakabasa sa kanya, parang magiging conclusion niya is, okay, medyo malaki yung p-value niya. Ibig sabihin, hindi siya ganun kumbaga ka-convincing yung results. Pwedeng ganun yung magiging interpretation, no? So kaya versatile in my own words, no, versatile si p-value because of that yung because of that na yung openness to different interpretations, no. Okay? Pero because open to interpretation siya, pwede ring maging ano siya, no. Pwede ding downside siya kasi hindi pala kumbaga dahil open to interpretation siya, pwedeng hindi siya as objective as we want it to be. Okay? And yun naman ang point ng nagre-research tayo, no, para maging objective. Pero ako, I like to look at both sides, no? So, pwedeng put p-value, pwedeng alpha value. Ang general na ginagawa ko is, if I'm doing research, no, is I check the p-value, compare it with the alpha value. If hindi siya pasok, then I can still make parang additional na mga remarks, no? Like, kunwari, kahit although the p-value is greater than the alpha value, we can say that at this ganitong level of significance, 5% or kunwari at this level of significance na 6.13%, kunwari ganyan, we can say that it is worth na investigating pa rin yung effect ni ganito sa ganito kasi ganyan, ganyan. So, pwede siyang ganyan. No? Kasi ang goal naman ng research is not to um, wala namang finality sa ano no sa mga research natin. So kunwari, if you made a conclusion about the research, you are not actually saying na okay, eto true na yung results ko, therefore no other research should be made kasi na-establish ko na sa research ko na ganito ang relationship. Hindi ganoon yung goal ng experiment, no? Ang goal ng experiment is to say na okay na-establish ko na mukhang may relationship sila. So it is based on statistics, significant yung relationship nila. So if this is an area that is worth studying again. So kaya always, kung mapapansin mo, parang may recommendation parati na, okay, magandang aralin to ulit. Parang ganyan. So yun yung goal ng research, no? Once we get a reject null hypothesis na result, we are saying na for future researchers, maganda na aralin nyo tong same na value and you may look into different factors pa. Pero okay na area to sa field natin na pag-aralan natin siya kasi mukhang malaki yung potential niya na significant yung relationship nila. So parang gano'n, no? Okay? So I hope that somewhat enlightens you guys, no, on how we can use alpha values, p values, etc. Okay.
Sir,
Go ahead.
sir, kapag po may failure to reject the
Hmm.
age na, ibig sabihin po ba comparable siya sa population mean para po dito sa two-tailed test?
Dito sa example natin?
Sa two-tailed po, dito sa first one.
Oo, parang ganun yung magiging ang engineering conclusion natin for that case is the sample mean is comparable to the population mean.
Thank you, sir.
Okay. Okay. So, try natin yung isang example, no? Ito medyo simple lang ang comparison of one mean, pero mas in my opinion parang mas ano no, mas relevant pagka tiningnan natin yung comparison of two means. Okay? Kasi not all of the time alam natin yung true mean, no? Or wala naman tayong established na values for the true mean. Mas okay na itingnan natin if two means are comparable to each other or not. Okay? So ito yung general na ano no, na by the way, may shortcut pala to, no? We can do a shortcut. Hindi, wala pala. 2 means pala dapat yung may shortcut. Okay, anyway, papakita ko na lang sa inyo. Okay, ito. So, nandito na tayo sa ito. Comparison of two means. So, dito, the null hypothesis will again be an equality, no? So, we are saying that the difference between mu1 and mu2 is equal to d naught, where d naught is the parang asserted na difference, no? But if we are just comparing two means, usually d naught natin is equal to 0. So if this is equal to 0, we are saying na mu1 is equal to mu2. Okay, so that is our null hypothesis. So dun sa example ko, for example, if you have product 1 and product 2, then our null hypothesis will be, if we are comparing the performance of product 1 and product 2, then our null hypothesis would be mu1 is equal to mu2. That is, we're saying now there is no difference between them. So D naught natin is equal to 0. Okay? So a possible alternate hypothesis will be, these are the possible alternative hypothesis, no? So if mu1 is, and again, kung D naught natin is assumed to be 0, no? So wala tayong alam na difference between them. We are saying na 0, yung mu1 and mu2 are comparable sila, or not comparable sila, then it's a two-tailed test. This will just become mu1 is not equal to mu2. Okay? Tapos dito naman sa if ang assertion natin is not comparable sila, then mu1 is, kung left-tailed test, then that is saying na mu1 is greater than mu2. Pag right-tailed test, that is saying na mu2 is greater than mu1. Again, that is for assume na no difference in between sila, between sa kanilang dalawa. Okay? So, may cases din na kailangan natin maglagay ng D naught, no? So, for a case would be, for example, if I say na product 1 claims that its let's just say speed, kunwari. Product 1 claims that its speed is 10 meters per second more than the speed product 2 provides. So pag ganun, ang asserted na difference is 10. Tama? So we can do mu1 minus mu2 is equal to 10 na to. Hindi d naught is equal to 0, but d naught is equal to 10. So yun yung mga cases na pwede tayong maglagay ng d naught, no? When we are asserting that there is a known difference between them. Okay? So, usually pwede natin matesto sa mga no, yung mga nagke-claim na kunwari yung product na to is 2 times faster, although hindi pwede yung 2 times pala. Yung mga this amount greater than this amount. So, top of my head, parang my product is 10 megapascals na stronger than the other products. So, if you do experimentation, ang D naught natin will be equal to 10 megapascals to be exact. Okay? So, ito, comparison of two means, halos same, again, this is just a rearrangement of the, again, a rearrangement lang siya nung estimation natin na formula. And you probably see some similarities na, no? Right off the bat. And ito, SP is just yung pooled standard deviation. So medyo mahirap mag-compute nito, no? Pero meron mga shortcuts sa Excel for this particular cases, no? So ito naman, case 4 is when you have known population standard deviation. Tama? Tapos case 5 is when uh, the population standard deviation is unknown, but the variances of the data sets are known to be equal, no? Tama? Tapos yung case 6 is when your variances of the data sets are both not equal tapos not known din sila. Okay? Yun yung case 4 to 6 natin. Okay? So ito, same yung formula ng SP, no? So pwede natin balikan na lang yung formula na yun if you want to do manual calculations. Tapos dito, ang mahirap na part is yung pag-compute ng ano, no? Yung, ang tawag dito, yung nu or yung degrees of freedom. Doon sa case 6. Tama? Yung medyo mahabang formula yung degrees of freedom nito eh. Itong case 6 na to. Okay? So, ang next natin is yung paired na observations, no? This is uh, when we have two data sets that are a sort of before and after yung treatment natin sa kanila. Pag ganun, then that is what we call as a paired observations, no? So, kumbaga each data point experiences both populations na gusto natin i-compare. Okay? So that is what we call as a paired observations. Tapos ang null natin dito is that the true difference is equal to a particular D naught value, no? So for example, ang case natin nito is when we have, let's just say na yung isang product or isang vitamin kunwari can give you 10 minutes more sleep, kunwari ganyan, or isang sleeping pill can give you 1 hour more sleep. So that is the parang observed difference dun sa paired observation mo before taking the pill and after taking the pill. Okay? So yun yung magiging D naught natin. Okay. So ito yung formula niya for the T statistic for the D naught, no? So ang ituturo kong method ngayon, you can still compute this manually, no? When I say manually, I mean sa Excel, ita-type in nyo yung formula. Pero ang ituturo kong method ngayon is yung mas shortcut pa lalo, no? Yung magta-type lang tayo ng isang line lang na formula, tapos makukuha na natin yung sagot. And pwede din, ituro ko na rin yung data toolpack ngayon. So, I leave it to you guys para mag-review nung paano yung pagka-manual methods yung ginamit natin using not necessarily manual, no, pero using these formulas, no. So kayo na mag-experiment nun. So let's do an example. So an engineer is studying the formulation of a cement mortar. He added polymer latex emulsion during the mixing to determine if this impacts the tension bond strength of the mortar. So the experimenter prepared 10 samples of the original formulation and 10 samples of the modified formulation. Okay? So parang ganyan. So using alpha is equal to 0.05, determine whether the variances of the two formulations are equal. Ay, variance pala itong equation. Pangit. Wait lang ha. Hanap muna tayo ng... ito. Okay, ito. Ito comparison of two means. So in a study conducted by the Department of Human Nutrition and Foods, the following data recorded on sorbic acid residuals, and this is the parang response variable na tinitingnan natin, no? Sorbic acid residuals measured in ppm in ham is immediately measured after dipping in a sorbate solution and after 60 days of storage. Okay, so assuming the populations to be normally distributed, is there sufficient evidence at the 0.05 level of significance to say that the length of storage influences sorbic acid residual concentrations? Okay, so try muna natin i-identify. No, obviously, this is comparison of two means. Pero gusto natin malaman kung anong case siya doon. Is it case 4, 5, 6, or 7? May clue tayo, no? Itong before and after. Anytime we see before and after, parang dapat nag-click na sa utak natin na most likely ano to. Case 7, no? Tama? Paired observations. Would you agree? Paired observations siya?
Yes po.
Okay, thank you for the feedback. So obviously paired observations ano kasi if you look at it yung ano natin may before and after, bukod dun sa before and after, each element, each kumbaga data point natin experiences both populations. So itong slice 1 na to experiences yung immediately after dipping in the sorbate solution, that is before storage. That's immediately mineasure din yung response niya after storage for a few hours or ilang days yun? After 60 days of storage. I'm sorry. So both na population na yun, na-experience niya tapos nakuha yung data for this slice 1. Tapos ganun din ginawa sa different slices. So obviously, ano siya, no? T-test, no, sorry, obviously, ano siya, paired observations. Okay? So, let's try to do this and compute natin siya, no? So, let's take this one. Oh. By the way, ano ako class, no? Magre-release ako ng quiz later. It will be a multiple choice na quiz lang siya. Wala kayong iso-solve masyado, no? More of ano lang siya. Identifying, medyo conceptual lang siya. So, kunwari, probably mga identification, tapos merong mga parts na i-identify nyo lang kung anong case siya, i-identify nyo kung anong type of probability distribution yung appropriate sa kanya. Mga ganong ano lang, mga tanong, no? Hindi siya ganun kahirap. So it probably will be just a 1 hour time quiz siya sa using Oblet. Tapos I'll give you 3 trials or baka 2 trials lang ibigay ko. Tapos we take the highest score dun sa trials. Okay? Okay, so try natin to. Let's do this example, no? Itong si storage. Kita na yung Excel, no? And remind nyo lang ako parati class, no? Kasi minsan na hindi ko na nasa-switch agad yung screen ko, no? Although marami naman nagre-remind. Thank you again sa mga nagre-remind kanina. Anytime na hindi ko na-switch, no? Okay? So, meron tayong ano, ganito. So, step 1 is the null and the alternative hypothesis. So, let's do, ang null natin is, null natin dito? That your mu, no, sorry. That the difference is equal to 0. Ganyan. So, kumbaga, hindi not natin dito. But if you want to state it, by the way, hindi natin na-state dito, class, no? Ito, inano lang natin in terms of mga symbols, no? Pero actually, pwede din natin i-state yung null hypothesis and alternative hypothesis as a sentence, no? Pwede rin yun. So, pwede, ang gawin ko dito is, there is no difference in sorbic, ano ginanap? In sorbic acid residuals of the ham before and after storage. Ganyan. Pwede natin i-state yan. Tapos, yung alternative natin is, ang i-assert natin is that there is a difference. And to be more accurate, pwedeng significant. Lagay natin ang word na significant. So, pag no significant difference, yung mu d natin, that is yung ano natin, no? Yung true difference sa paired observation is equal to 0 kasi we are saying na wala silang significant na difference, no? Or mu d is not equal to 0. Okay? So, in this case, Kasi ang tanong lang, no? And ito, class, we need to be careful dito, no? And let's balikan natin, no? Parang ang tanong niya is, assuming that the populations to be normally distributed, is there at 0.05, can we say that the length of storage influences sorbic acid residual concentrations? Okay? So, notice yung language na ginamit niya. Sabi niya, nag-i-influence pa daw siya ng sorbic acid residuals. Okay? So, influence can be both ways, no? It can influence it positively or influence it negatively. Tama? So, it can either raise the sorbic acid levels or pwede ding i-lower niya yung sorbic acid levels. Tama? So, if that's the case, should this be a one-tailed or two-tailed test? Sige, try to think about it. So, si Kenneth and Andre answered two-tailed. That is correct, no? Kasi kung influence lang yung term na ginamit and there is no mention of which direction we should take, then therefore, dapat two-tailed test to. Pero if the problem said specifically na, so baguhin natin yung problem, no? Kunwari lang sinabi niya na at level of significance 0.05, can we say that the length of storage increase the sorbic acid residual concentration? Then that will be a one-tailed test. Pag sinabi niyang increase or based sa data mukhang nag-decrease siya, so pwede niya sabihin na, can I conclude that the length of storage decreases the sorbic acid residual concentration? Then kung ganyan yung ang pagkasabi ng problem, then we should do a one-tailed test. Okay? So again, class, always look at the language, no, kung paano state yung problem para malaman nyo um, kung two-tailed test ba siya or one-tailed test. Okay? So ito, there is no significant difference. Tapos there is, or pwede rin gawin natin is, ito yung pagka-state ko, no, pero you can also state it the way the problem stated it, no? So ang sabi ng problem is, I can, let's copy, no? Pwede ang sabihin ko lang is, there is no ito yung pagka-state ng problem, no? Sufficient evidence to say that length of storage affects the sorbic acid residual level. Pwede ganyan, no? So you can if you want to state it exactly how the problem states it, no? Walang problema doon. Okay? So these two basically mean the same thing, no? Itong significant difference in sorbic acid residuals of the ham before and after storage, and ito there is no sufficient evidence to say that length of storage affects the sorbic acid residual level. So you can state it either way. If you want to be sure, ang suggestion ko is you follow what is asked in the problem, no? So i-state nyo lang kung ano yung pagkasabi niya. Pero kung masanay kayo dito kasi all throughout yung kahit yung senior high nyo, no? Senior high and kung nag-basic statistics kayo, usually ganito talaga yung pag-state, no? Itong first statement na there is no significant difference, there is a significant difference, yung ganun. So nasa inyo na kung ano yung mas comfortable kayo. So ito, step 2 is to establish an alpha level, no? And we say alpha is equal to 0.05, sabi ng problem. And if it's not given, we always assume na alpha is equal to 0.05, no? So step 3 is identifying. So our test statistic will be this is case 7. Therefore, gagawin natin is case 7. So therefore, this is we use the t-test, no? Okay. So step 4 is we can compute for the t-value, no? Pero the faster way to do this is actually just get is to just get the p-value, no? And I'll show you the very quick method to do this. We use t.test. Okay? Tapos, we choose the array. Ito yung array 1. Next, we choose array 2. Yan. Then we do the type of distribution. No? So, if it's a one-tailed or a two-tailed, and in this case, we do a two-tailed distribution. No? Tapos, we have three choices here. We have a pair distribution. Meron tayong two sample equal variance. Tapos meron tayong two sample unequal variance. So if you notice itong pair, this is case 7. Two sample equal variance is your case 6. No, sorry. Case 5. Tapos two sample unequal variance is case 6. Okay? Tapos si case 4, hindi actually t-test si case 4, no? Kasi if you remember, yung case 4, gumagamit ata siya ng Z value yung gamit ng case 4, no? Or pati ba si, tama, si case
Yes.
4, Z,
Yes po,
thank you,
Z po.
thank you. So kaya siya, hindi siya kasama dito sa t-test, no? Okay, so ito, madali lang. This is two-tailed, tapos paired siya, so we choose 1, and we do this one. So, automatic p-value siya. So, pwedeng step 5 natin. Sorry. Ito pala case step 3 pa pala to, no. Ang step 4 natin is you make the conclusions, no. So, since p-value is less than alpha, then we reject H naught. And therefore, ang magiging conclusion natin is that reject H naught. So, there is sufficient evidence. Hindi pala siya. There is sufficient evidence to say that length of storage affects the sorbic acid residual level. Okay? Okay ba yun? May mali na ba? Or you can do another example, pero kung isa lang sa unang method. Pwede naman isa lang. Either you use p-value or you use alpha values. So pwedeng, eto, notice na since this is the quick method, no? P-value, hindi na ako nag-compute ng t-count. Hindi na ako nag-compute ng t-count, hindi na rin ako nag-compute ng t-crit. Kasi doon sa itong Excel kasi automatic nagko-compute na siya agad ng ng p-value. So another method, mas hindi ko sure kung mas gusto nyo tong method na to. Pero you can do ito data. Data ulit tayo, data. Tapos data analysis tool pack dito. Tapos what we do is hanapin natin yung t-test na gusto natin. So we have t-test and ito may z-test, no, for comparison of two means. Ito actually yung case 4. Okay? So ito case 4, case 6 unequal variance, case 5 equal variances. Case 5 nga ba to? Equal variance, sama. 5 equal variances, tapos t-test for paired observations. Okay? So piliin natin to. Okay? So variable range 1, this is this range here. Tapos variable range 2, this is this range. Tapos wala tayong, actually pwede nating para mas maganda. Sama natin yung label. Okay? Before storage, ito after storage. Tapos hypothesize mean difference. Wala tayong hypothesize mean difference naman. So dapat 0 siya. Pero kung may sinabing value, no, na may kine-claim na value, kunwari after storage, dapat it should be 100 ppm less, then therefore 100 ppm ilalagay natin dito. Pero since dito wala naman tayong kine-claim, 0 lang. Okay? Tapos lagay tayo ng labels kasi pinili ko yung range na pinili ko, nilagay ko ng labels para pag nilabas niya yung final output, at least kita kung before or after ba siya na storage. So alpha is 0.05. And let's do output range. Lagay lang natin dito sa, probably do here, no? Dito sa gilid. Okay? So, if I press OK, variable range, sorry. Mali yung ginawa ko. Variable range 1 is this one. And variable range 2 is this one. Okay, nagkamali ako ng pindot class. Okay. So, let's do okay. Tapos, maglalagay siya ng results, no? So, this is the results of the t-test. So, meron siya nakalagay na ito before storage. So, this is 583 daw mean, 3 to 4. Variance, ito, observations is number 8. Ito, Pearson correlation coefficient, 0.86. Hypothesized difference is 0. Degrees of freedom, 7. Tapos ito, nakalagay din yung t-stat. Tapos, this is the one-tailed probability, no? Which is 0.015. So, ito is, if one-tail yung ginawa natin, half lang nung nakuha nating p-value dito. Tama? So, that's 0.01. And notice na if I do equals, ito times 2, gives me the same value dito. Okay? So, and nandito rin pala ang 210. No? Ito 3186. Tapos, itong t-critical, pwede rin siyang i-compute din niya. Tapos, if ganito yung ginawa nyo, then you can use since t-crit, also since t-calc, which is 2.67 in this case, no? Babaguhin ko na ito, no? We call, lagay natin t-calc to. Ito t-crit on one tail, tapos ito t-crit ng two tail. So, two tail yung ginawa natin. So, ito yung kukunin natin, no? So, if you notice, since t-crit is greater than since t-calc, that's 2.67, is greater than t-crit, which is 2.36, then we reject H naught. Pwede ganyan, no? If we use this table. Okay? Lipat lang natin somewhere dito. And gawin ko na lang ganito. Okay? Okay. So, yun. You can use this one, mas mabilis, or this one. Ito, mas visual siya, no? Mas madaling maintindihan if you want to go this route. So, you can choose either one. Posible ba na magkaiba ang makuha conclusion? Hindi posible. Dapat same lang. Gumamit ng shortcut. Yes, pwede naman gumamit ng shortcut. Pero, pag gumamit kayo ng shortcut, huwag niyong burahin to. Dapat ipakita nyo na ito yung solution. Kasi magiging part to ng solution nyo. Itong values na nakuha nyo dito. Okay? Okay? So, ano pang pwede natin ma-conclude dito? Actually, itong t-calc na to, pwede actually tayo kumuha ng p-value dito, no? So, if you do t-test, t.dist ng value na to, tapos degrees of freedom na to, and cumulative, we do, this is from the left side, no? Mas maganda kung gawin natin .rt pala. May RT ba siya? May RT siya, no? .rt. Degrees of freedom is this one. Then, we still get the same critical value, p-value sa ano, no? Tapos if we know that this is a two-tailed test, pwedeng .2t, and we get 0.0318, which is the same as yung nakuha natin dito. Okay? So, tama ba? Okay? So, yun. Ang disadvantage nitong nitong t-test na to, hindi ka pwede mag-input ng perceived na difference or asserted difference between the two data arrays. Okay? Kasi notice dito, parang assumed parati na D naught is equal to 0. Ang maganda dito sa kabila, itong t-test, yung gumamit ng data analysis toolpack is that pwede nyo actually i-input yung gusto nyong hypothesized na difference, no, between the two data sets. Okay? So yun, just choose which one you like better, kung ano yung mas comfortable kayo, and then you can stick with it. No? And if you want, you can also use the yung manual method. Okay? So we have room for, I think, one more example. Tapos feel ko kailangan natin yung example din ng, ano no, um, maganda sana yung example na dalawa yung i-compute natin, no? Nasaan ba yun? Wala yung problem. I'm trying to look for it, class. No, wait lang. Ito. Maganda to, class. Ito, dalawa yung ano natin, no? Ito. Okay. I think we can do this in 10 minutes, no? Okay. So ito, meron tayong two data sets. Merong modified and unmodified. So meron tayong nilagay na formulation para sa cement mortar to. And let me just transition dito na. Okay. So an engineering is studying the formulation of cement mortar. He added polymer latex emulsion during the mixing to determine if this possibly impacts the tension bond strength of the mortar. The experimenter prepared 10 samples of the original and 10 samples of the modified. Okay? So gusto natin i-compare yung nagiging response nila. Okay? So, the thing about this type of problem is, first let's identify na kung ano yung type of ano siya. Meron na kayong idea? Anong case? Case muna. We're comparing two. Would this be, there are equal samples, no? 10 samples original, 10 samples modified. Would this be a paired observations? Some say case 7 paired. Okay. So actually hindi siya case 7, no? So but I would understand kung bakit naisip nyo na case 7 siya kasi mukha siyang before and after, no? Pero the thing is, ito pala yung mahirap, no? Kasi hindi nyo alam kung the way we prepare these samples kasi is we can't prepare them such that yung isang sample 1 is the same sample na gagamitin natin and lalagyan lang natin ng additive para ma-produce yung modified formulation. So dito, separately pinrepare mo yung 10 samples with the original formulation and separately din pinrepare mo yung 10 samples with the modified formulation. So, kumbaga walang 1:1 na correspondence. So, hindi ibig sabihin na ang sample 1 dito sa original is the same sample for the sample 1 dito sa modified formulation. So, if that's the case, this is actually either case 4, 5, or 6. Tama? So, definitely hindi siya case 4 kasi walang standard na deviation na binigay. Correct? Pero hindi siya case 4. So either case 5 or case 6 lang siya. Kaso, if you notice, wala kasing binigay na ano, no? Yung variance information, hindi natin alam kung yung variance ba nila is equal or not or comparable or not. Tama? Nag-agree ba kayo?
Yes po, yes po.
Hindi siya binigay, no? So, in this scenario, kailangan actually natin mag two-part na analysis. So, first is i-analyze muna natin kung variances are equal ba, tas tsaka natin i-analyze yung means nila based on the results of that test sa variance. So, yung test sa variance natin is actually falls under either case 8 or case 9, no? So pagka case 8, yung test of variance natin falls under case 9. Okay? 'Di ba? Case 9 is when we are comparing two variances. So gusto natin i-compare yung variance ni dataset 1 versus variance ni dataset 2. Then from there, i-test natin kung if it results na equal sila, then ang gagawin natin is magki-case 5 tayo. Tama? Pero kung ang results ng case 9 natin na test is is not equal sila, then ang gagamitin natin is case 6 naman. Okay? So let's do that, no? And again, ang ipapakita ko ngayon is shortcut lang, but you can very well do this manually, no? So gawin natin is hindi ko na ilalagay yung steps, no? So lagay ko na lang case 9. Kasi ilalagay ko na lang yung steps para mas malinaw. So dito sa portion na to, let's do case 9. And step 1 is the hypothesis, no? H naught and H1. So ang hypothesis natin is the variances are equal. var1 is equal to var2. Thank you sa reminder, Martina. Ito. I'll do 2 cases, no? Case 9. So case 9 muna. So I'm testing for variances. Okay? So case 9 is H naught dito is var1 is equal to var2, meaning yung variances are equal, or H naught natin is var1 is not equal to var2. Okay? So step 2 natin is establish a alpha. Walang binigay ata sa problem. So let's do 0.05 na alpha. Tapos step 3 is doing the test statistic, no? This is again case 9 muna to. Case 9, and we do the F test. Okay? So we can do 2 methods, no? Pwede p-value diretso. What we do is F test. And we just do etong array na to versus array na to. Okay? Tapos it returns to us a p-value. And if we do step 4, we can say na etong since p-value is greater than alpha, then we accept H naught or fail to reject H naught, no? But let's just use accept. So if we accept H naught, then for step 5, we can say the variances are unequal. Tama? So since variances are unequal,
Hindi po ba, sir, equal po? Kasi inaccept po yung
sorry.
H.
Tama. That's correct. Thank you. So the variances are equal. Since the variances are equal, then we can say since variance are equal, then we do case 6, case 5. Tama? Tapos dito, case 5 na tayo, step 1. But before we proceed to case 5, no, try muna natin yung isang method. So another method is we do data. Again, punta tayo dito, data analysis. Then we do, hanapin natin yung F-test. Ito, F-test to sample for variances. Ay, hindi pala nakikita. Sorry. Hindi nga pala nakikita yung pop-out. No? Ito na lang. So, gawin natin is data analysis. May lalabas na ganito. So, itong kanina yung pinakita ko, no? Hindi nyo pala nakita to. Sorry. Basta ito, this is case 4, case 6, case 5, case 7. Okay? Tapos dito, nandito si case 9, no? Ito, F-test to sample for variances. So we choose that, F-test to sample for variances. Tapos variable range natin for dataset 1 is this one. Tapos unmodified is this one. Okay? Tapos lagay natin ng labels kasi pinili ko pati yung ano, no? Tapos 0.05 output natin, let's just output it somewhere dito na lang, no? Sa tabi niya. Okay? So press OK. Kasi ito siya. And you'll see na this is the probability na F is less than yung calculated F. Isa din pala to sa notation na ginagamit ng ibang textbooks class, no? So yung calculated value binibigyan nila ng capital letter, tapos yung critical value binibigyan nila ng or dinidenote nila as a small letter. So pwedeng ganito. Pero basically this is F calc, and This is F crit. One-tailed lang yung ginawa nila dito, no? So, later sasabihin ko kung bakit one-tailed test siya. Pero kailangan ng ANOVA, no, para make sense yung. Pero later. I-explain ko kung bakit the F test is always a one-tailed test, no? Okay? So, dito, etong F crit siya, one-tailed yung ginamit nila, no? So, ito F calc is, this is also for the left tail test to. Okay? So, ang gagawin natin is, i-compute natin yung p-value. Etong p-value to is for one tail. So, etong lumabas dito is the p-value for the two tail. So, if we multiply this by 2, then we get the same value ito. So, if two-tail test yung ginamit nyo for the F test, then dapat ang gagamitin natin is etong i-multiply dapat natin yung makukuha natin dito. Okay? Tapos similarly, pwede rin ang gawin natin is from the F calc, ito, gawin natin is F dot this dot and this is from the left tail, no? So, hindi tayo mag-RT. Ano, this is from the, tama, from the left tail to. So, degrees of freedom 1 is 9. Degrees of freedom 2 is this one. And we do cumulative distribution. Okay. So, this is from, no, sorry. One tail test pala to. So, this is from the right tail. So, ang gagamitin natin is .RT. So, .RT siya. So, we get the same value dito na. Ito, 23923. And if we multiply that by 2, we get the p-value for a two-tailed test. Okay? Okay. Tapos, pwedeng ang gawin nyo is, since p-value is greater than alpha, we accept h0, or pwede rin since f-calc is less than f-crit, then we accept h0. Okay? So, since variances are equal, then we do case 5, no? And case 5, step 1, h0 muna. H0 is equal to, yung mu1 natin is equal to mu2 kasi kino-compare lang naman natin sila, no? So again, walang sinabi kung is mu1 greater than mu2. And in fact, if we look at the problem, no? Kung ano yung sinabi ng problem, ang pagka-state ng problem is he wants to know if this impacts the tension bond strength. Ano wala yung ano? Ito yung term na ginamit niya. This impacts the tension bond strength. So walang sinabi kung nag-i-impact ba siya negatively or nag-i-impact siya positively. Okay? So, pwede ang gawin natin dito is wala yung ano ko. Saglit lang class. Nawawala yung cursor ko. Yeah, bumalik na. So, ito, mu1 is equal to mu2, yun yung h0 natin. Yung h1 natin or alternative hypothesis is mu1, mu1 is equal to mu2. Tapos ito, mu1 is not equal to mu2. Or, pwede rin, the formulation does not impact. Ano yung term na ginamit niya? Tension bond strength. Or the additive lang. Sabihin ko na, additive does not impact tension bond strength. Pwede ganito yung ano ko pagka-state, no? Tapos pwede rin the additive does impact tension bond strength. So, pwede ganyan yung pagka-state ng class, no? Instead of using mu1 and mu2. Pwede rin kung gusto nyo mas mahaba, there is a significant, there's no significant difference between the tension bond strength of the modified versus the unmodified. Tapos there is a significant difference. Okay? So ito, simplify lang natin. Does affect, does not affect. Or does impact, does not impact. Okay? Step 2 is alpha equal 0.05. Tapos step 3, this is case 5. And therefore, we do t-test. Yung gagamitin natin. So, I can just do p-value na lang gagawin ko class, no? So again, walang direction, just impact. So this is a two-tailed test. So p-value, t.test ng array 1 and array 2. This is a two-tailed test. And sabi yung equal yung variance, no? Based on yung result ng case 9 natin. The variances are equal. Therefore, ito yung gagamitin natin. Okay? So 2. So we get itong value na to. 0.04. Step 4 is since p-value is less than alpha, then we reject h naught, and therefore our conclusion would be the additive does impact the tension constant. Okay? So, i-leave ko na sa inyo yung pag-experiment sa ano, no, yung different cases. So pwedeng try nyo naman yung ano, no, yung data analysis tool pack. Tapos try nyo din yung manual calculations kung mas feel nyo yon. So yun. There are many ways to solve it, no? So these are just some of the ways. And siguro magsisend na lang ako ng article to show why F-test are all considered as one-tailed test lang, no? Pero the basics of it is the F-test is what we call as a goodness of fit na type of test, no? So if you imagine it, siguro ano ko, no, ipapakita ko yung parang gist ng kung bakit F-test is one-tailed test. So when we do an F-test, parang ito siya. So ito, this is two-tailed, no? So ang sinasabi sa region na to is that meron tayong tinatawag na ang tawag dito is a goodness of fit. So parang tinatry nila i-fit yung data with what is expected dapat, no? Goodness of fit data. Pagka nandito ka sa region na to, this is a point wherein data does not fit. Okay? So, yan yun siya. Pagka nasa etong right tail ka, sobrang layo ng data mo na hindi talaga siya nag-fit. Tapos dito sa left tail, parang sinasabi dito is data fits too much. Parang ganyan. So it doesn't make sense, di ba? Wala namang parang sobrang nag-fit yung data mo. So kaya always si F-test should be a one-tailed test wherein tinetest mo kung nag-fit ba yung isang data or not. Okay? So kung one-tailed test siya, tanggalin natin to. Malilipat siya dito. So mas focus tayo if the data does not fit at all. Kasi parang hindi naman natin concerned kung the data is fit, the data fits or yung results natin fits too much with the model or what is expected of it. So hindi nagme-make sense or nagme-make sense siya pero hindi practical. Hindi siya nagme-make ng practical sense, no? Itong statement na to. Okay? So that's why we always use the one-tailed test. And in fact, dapat pala ang ginamit natin dito is the one-tailed test, no? Dito sa p-value na to. Although pag ginamit natin itong f-dot test kasi always two-tailed siya. So what we can do is divide na lang natin by 2. So that gives us the one-tailed F-test for case 9. Okay? Pero if you, kami hindi naman kami masyadong strict, no? If you happen to use, kunwari doon sa case 9, no, ang ginamit nyo is a two-tailed test, then we will still accept that answer, no? Pero it should be a one-tailed test. And if you use data analysis toolpack, automatic naman na one-tailed yung gagamitin niya. So, yun na lang yung gamitin nyo. Okay? Um, may question si Martin, no? So, gagamitin lang po ba ang case 9 kapag yung problem is either case 5 or 6 tapos walang sinabing variances? Uh, you can use that, you can use case 9 for that, no? Pero there are cases wherein, ano din, no? Specifically, tinatanong din about the variance, information about the variance. So, posible na wala ng case 5 or case 6 na kasunod, posible na case 9 lang talaga tinatanong na. Pero most of the time, pag walang binigay na kung obvious na case 5 or case 6 siya pero walang binigay na variances, kailangan dumaan kayo sa case 9. Meron nata dito ng ano, no, example of purely case 9. Ito. Ito yung example ng purely case 9 siya. So, ito daw, aflatoxins produced by molds on peanut crops must be monitored. A sample of 64 batches of peanuts reveals levels of 24.17 ppm on average with a variance of 4.25 ppm. So, let's test the hypothesis that the true sigma value is 4.2 ppm against the alternative that the true sigma value, sigma squared, that the true variance is equal to 4.2, and that alternative is that the true variance is not equal to 4.2. In this case, this is actually, hindi siya case 9, no? Pero this is case 8. Tama? Kasi we are trying to, gusto natin malaman if totoo ba na, kung ano yung true value ng mean. Kung 4.2 ppm ba siya. Okay? So case 8 to actually. Kasi parang looking for the ano, no, comparison of a sample mean with the true mean, kumbaga. Okay? So chi-squared yung gagamitin dito. Same dun sa example sa ano, no, estimation. So as a estimation, 'di ba, chi-squared ginagamit natin pag looking at the variance, a single variance, no. Okay? So yun. So yun, sensya na nag-extend tayo ng konti, no, 5 minutes. Pero I hope you learned more, and this is yung hypothesis testing is very ano siya, no? Mahirap siya makuha agad-agad, kailangan talaga ng practice. So yung ay pag-identify pa lang ng case, tapos yung paggamit ng mga statistical tools natin, tapos yung pagkuha ng ano, no, pag-derive ng conclusion based doon sa results na nakuha natin. Tapos siguro ang very tricky part is determining if it's a one-tailed or a two-tailed test. Tapos once you determine if it's a one-tailed or two-tailed test, yung alpha value pa, no, yung parang ah, parang nakakalito kung if i-divide mo ba by 2 yung alpha or hindi mo i-divide by 2 yung alpha. So always go back to the illustration, no? If nalilito kayo, balik kayo sa illustration tapos tingnan nyo kung paano kino-compute ni Excel. Tapos from there, pwede nyo na ma-decide kung i-divide nyo ba by 2 or not. So nasa tool pack din ba ang case 8? So let's look, no? I'm not quite sure. So hanapin natin. Data analysis tool pack. Chi-square. We're looking for chi-square. Unfortunately, wala. Oh. Wala, no? F-test for two sample. Wala, sorry. Wala siyang, mukhang kailangan nyo i-manual si case 8, no? Wala siyang quick na method. Let's just type chi-square, no? Kung meron ba? Chi-square test. Iba to si chi-square test. Itong chi-square test na to is you have an expected range and you have an actual range, no? So, hindi ito yung hinahanap natin na chi-square test, no? So, hindi nyo pwede magamit to for your case 8. Later, pagka sa start ng second exam coverage natin, ito actually yung unang lesson, no? Itong chi-square test. So, makikita nyo siya kung paano siya gagamitin. Okay?
Sir,
Go ahead.
pwede pong magtanong tungkol po dun sa project proposal po.
Okay.
Kasi po, nung tinignan ko po sa schedule, next week na po siya. Ano po yung mangyayari po doon?
Ay, talaga. Nag-groupings na tayo, no? Tama? We will use the same groups.
Opo.
Sige,
Opo.
i-extend na lang natin, no? Kahit next meeting, kahit ano muna tayo, or sa 9, pwede ba tayo mag-meet ng 9 sa Friday? Tapos, pero consultation lang.
Okay.
Or busy ba? Kung busy kayo, pwede namang online. On the 9th, kahit mag-ano kayo, consult,
Ano po? Araw ng kagitingan po.
ay talaga. Extend na lang natin. I'll ask Sir Terence, no, para bigyan din ng
Okay po.
extension yung kabilang class para fair naman. Pero Pico, wala namang problema. Ang maganda lang na makapag-proposal kayo agad kasi baka lang mabitin tayo sa oras, no. For this sem, kahit hindi masyadong in-depth yung gawin natin, yung basta yung doable lang. I'm highly suggesting topics that have data that can be extracted online, no? So something like kunwari may mga public data on satellite movement or something, or public data ng amount, pwedeng COVID related, kunwari public data on COVID cases, tapos gusto nyong kung may sorting siya, tool, pwede nyo i-sort na kunwari by region, kung does the region affect the COVID case. Actually, magandang idea yun. Kung gusto nyo, puro COVID tayo lahat. Or baka mas stress kayo lalo pag iniisip yung COVID cases. So kayo. Ako, I think the COVID na topic is very, sobrang dami. There is a plethora of data available online, no, na pwede nyo extract, tapos pwede nyo siyang sort out yung data by depending on pwedeng mga regions, pwedeng parang yung di ko pa alam ko maraming factors na na pwedeng i-sort doon sa sa mga readily available na So COVID would be a good topic if you want. Pero check lang natin yung project proposal na pala. Okay. Sige. I think we can move this, no? Kasi hindi naman necessary na dito siya. Pero kahit lang, at the very least sa April 14, kahit wala kayong project proposal pero may list of list of topics na interested kayo, yun na lang muna hingin ko on April 14. Yun na lang. Okay, kaya ba yun? So pag-usapan nyo lang sa group nyo, isip kayo ng mga 3 topics na interested kayo, tapos i-weigh natin yung pros and cons per topic kung ano yung maganda. Okay?
Okay
Ganun na
po,
lang.
sir.
Okay. Thank you.
So, sir, yung ganap lang po next week po is yung exam po.
Wait lang. Exam
Okay.
is 16 to 19. 16 to 19. Hindi. Next, sa 14, magdi-discuss na pala tayo ng one-way ANOVA. So, siguro shorten ko na lang yung discussion sa one-way ANOVA. Ganun na lang gagawin natin. Shorten ko yung discussion ng one-way ANOVA. Parang, pero this requires na kailangan magbasa na kayo ahead of time, no? Tapos, ang gawin ko lang dito is parang recta example na lang to. Example, tapos kung paano nyo gawin siya in Excel. Okay lang ba yun?
Yes po.
Tapos yung concepts, I'll leave it to you guys na ibasahin ko what ANOVA actually means. No? Okay? Ganun na lang. Tapos half of the time is spend natin for the examples ng ANOVA, tapos half of the time project proposal tayo. Tapos meron palang tanong sa yung 3 tries. Sa quiz yun, Martin. Yung exam 1 try lang siya. Tapos sir, hanggang kailan po maging available yung quiz na ibibigay nyo? Hanggang before exam. So April 16 or April 15 midnight. April 15 midnight, i-close na yung quiz. So you have ample time to solve it, no? And again, it's a simple quiz. Ang i-cover lang is probability, hypothesis testing, pati estimation. So, wala kayong i-solve dito, most likely, or kung may i-solve man, sobrang simpleng calculation lang. Pero this is, I'm thinking a 20-point quiz lang siya. 20-point quiz, good for, i-estimate ko pa, i-try ko i-solve on my own, tapos estimate ko, tapos either 1 hour to or 1 hour and 30 minutes. Yes, conceptual lang siya. Most likely, ang quiz is parang identifying kung anong case siya, identifying kung anong probability distribution ang gagamitin, yung mga ganun lang. Yes, sa OVLA siya ma-access. Multiple choice. That's correct. Multiple choice. Tapos etong time restraint sa exam, yung time restraint ng exam, it's a 3-day exam, no? So it's from April 16 to April 19. So it's a take-home exam. Okay? Nasagot ba yung tanong? Meron ba akong hindi nasagot na tanong? Where ba yung ng purpose? Example ng topic for proposal. Yung example topics is, kung gusto nyo, I can send a parang list of topics from the previous na offerings ng MMME14 para may parang idea kayo kung anong gagawin. Huwag nyo na lang kopyahin yung exact topic nila. Pero pwedeng para magkaroon lang kayo ng inspiration. No? Pero some of the unique topics na nakita ko is merong yung na nag-stick talaga sa akin. No? Some topics were yung meron silang kinuwang paper. Tapos from that paper, may na-extract silang data. Tapos yung data na yun ginamit nila or iba yung analysis na ginawa nila. Pero statistical analysis pa rin siya. So kumbaga hindi na nila kailangan i-ano yung science, no? Kasi hindi naman nating goal na i-understand masyado yung science. More of para lang ma-demonstrate kung marunong kayo mag-statistical test. So hindi na kunwari ang data na yun is specifically for tensile test eh. So may tensile test value sila tapos compare sila ng different na kasi marami yun eh. Mga tensile test results for kunwari yung for alloy containing nickel, alloy containing antimony, parang ganun, different alloying elements. Tapos ang ginawa nila is sinort nila yun, ginroup nila yun para pwede nilang ma-analyze using ANOVA, correlation, mga ganun. So isa yun sa mga interesting na nakuha ko, na nakita ko. Yung iba, isa pa is yung, ano ba yung isa? Yung mostly nagsa-survey yung magsa-survey sila ng yung pinaka-common yung mga jiwa, yung parang amount of sleep versus jiwa, amount of coffee intake versus jiwa, yung mga ganun. Yun yung sa mga social science na na type of studies. Ano pa ba yung interesting? Parang di ko na maalala yung iba, no? Meron ata kumuha ng meron yung isa pa, yung traffic data. Kumuha sila ng data from isang website. Hindi ko alam kung sa Philippines yun na traffic data, no? Tapos nag-ano sila ng correlation. Hindi ko sure kung ang correlation is yung time of day versus yung traffic or parang region ata or something. Basta there is a certain factors na kinuha nila tapos tinignan nila yung traffic information. Yung contents ng project proposal, ibigay na lang namin yung niya, yung parang format. Pero on the 14th, hindi muna tayo project proposal. More of topics lang. Listing of topics lang. Kahit hindi full-blown proposal muna siya. Okay na? Other questions? Pwede ko palang i-end na yung recording.